Hello everyone. Today we will be discussing about the cell structure and signal transduction. This question came in the year 2015 in the biochemistry section and the question number is 15. It came for 2 marks. The question is stated as the value of del G at 37 degrees Celsius for the movement of calcium ions from the endoplasmic reticulum where calcium is 1 millimolar to the cytosol where calcium ion concentration is 0.1 micromolar at minus 50 millivolt membrane potential is, and they have asked the answer in kilojoule per mole. So what is important to solve this question is to get the idea of membrane potential and how to calculate it. And this is, you can be taking an analogy with this question with your electrochemistry questions where you have been asked about the electrochemical gradient or electrochemical potential. The electrochemical potential is similar to this membrane potential. So first let us look into that what is the membrane potential. To understand that, what is important is to know this Nernst equation. So Nernst equation give a relation between the electrochemical potential at any known temperature, pressure and concentration. Okay, so they actually relate this electrochemical potential with your reaction quotient. Okay, and it is related to a known temperature. Okay, so the equation relates the reduction potential of the cell at a non-standard condition to that of standard conditions. So your E naught cell is the standard electrochemical potential, that is at standard conditions 298 Kelvin temperature, 1 atmosphere pressure and concentration should be 1 molar. If these are the conditions, then the E naught is your that condition, the electrochemical potential is your E naught. And at a temperature T, pressure P and the concentration C, the electrochemical potential is defined as E cell. And this R and T is your temperature, okay, R is your gas constant, N is the number of electrons that is transferred in the reaction. So that is very important, how many number of electrons, net number of electrons is getting transferred in the reaction is N. And Q is your reaction quotient. So if your reaction is like A plus B giving C plus D, and here in the coefficient of C this is M and in the coefficient of D is N. So the reaction quotient will be the concentration, the product of the concentration of your products. If you multiply the concentration of your products, that is C and D, to the power their stoichiometric coefficient and divide it with the product of your concentration of reactants, then you will get the reaction coefficient or reaction quotient. Okay, so this value if you find and then you put it in this equation to get the electrochemical potential. Now there is another important relation to calculate this electrochemical potential with del G value, that is the free energy, gives free energy. Before going to that, similar to this equation, you can also define del G in relation to the temperature and reaction quotient. So that is given by del G equal to del G naught plus RT ln Q. This del G naught is again the standard gives potential energy. So this is in the standard condition, that is when your temperature is 298 Kelvin, pressure is 1 atmosphere and the concentration is 1 molar, then the gives free energy that is there, that is known as the standard gives energy or del G naught. Okay, so these are the two important equations that you should remember while solving this question. Now, once we find the electrochemical gradient, then what is the relation of this electrochemical potential with the gives free energy? That is given by this equation, that is del G naught equals to minus N F epsilon naught or E naught, which is your electrochemical potential that you have found out from this formula. And for standard gives free energy, it should be standard electrochemical potential. What is F? F is the Faraday's constant and N is the, again, the number of electrons, the net number of electrons that is transferred in that reaction is N. So once you get all these values, you can actually relate free energy with the electrochemical potential or membrane potential. Now if we go back and look into the question, what is given here is the membrane potential, and they have also given the concentration of the calcium when it is moving from the endoplasmic reticulum to the cytosol. So how much net amount of concentration is getting changed, that is also given. So if you think that this calcium in the endoplasmic reticulum as your reactant, and when it is going to the cytosol as your product, then you get the values of your reaction coefficient. Okay, the temperature is given here 37 degrees Celsius. What has been asked is to find the membrane potential. Okay, so let us look into what will be the solution. So the first one will be the del G naught can be actually calculated by this equation. The Gibbs free energy can be calculated by this equation, that is del G naught equals to NF delta E. And here that if you find that for calcium, so Ca2 plus, how many electrons are getting transferred? So in the reaction it is getting transferred, 2 electrons are getting transferred. What is the electromotive force here? E is equals to minus 50 millivolt, and Faraday's constant is given as 96500 coulomb. Okay, so now you need to find the del G naught value first. So once you find the del G naught value, that comes in kilojoule per mole. Now if you go back into your question, it is said as membrane potential. Okay, and you have found the del G naught value from here. But this del G naught value is not sufficient. Right, this potential, Gibbs free potential, is not sufficient because you want this del G value. This is the standard del G naught value that you have found out. Now you need to find the del G value from here. So for that you require this equation. The R value is given, T value is given. I have said the concentration of calcium in air, that is your A, that is your reactant, that is 1 millimolar. And calcium concentration in cytosol, that is 0.1 micromolar, that I calculated into millimolar because A is in millimolar. You should be remembering that these two units should be equal, and then if you put those values in this equation, then you will be able to solve what is your del G value or what is your membrane potential. So the answer to this question is minus 33.4 kilojoule per mole. For your reference in this course, you can follow these two lectures. So the first one is Introduction to Cell Biology by Nagaraj Balasubramaniam and Professor Girish Ratnaparkhi of IISER Pune. And the second course is of Cell Biology IIT Guwahati by Dr. Sanjukta Patra. And the two links of the course is given. You can go through these courses to clear your concepts in the cell biology part.